Hello. 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 Thank you for joining us live today. Today I'm going to show you how to export a GEE code. Okay. So for our case today, we are going to learn how to um, display the Sentinel-2 image and display an DEM then in Google Earth Engine. So in our session now, maybe I can share my screen. Let me start sharing my screen. So for this case, maybe I can share this screen here. So let's see. Hope you can see my screen. So now I will just open uh, Google Earth Engine. Okay, you can see it. So I will just open Google Earth Engine, GEE. Okay, go to Google Earth Engine, the link that appears first there. So for this case now, we are going to open the code editor. And at the code editor, you will find that in most cases recently, you will notice that there is a caution that has been put here. So don't worry about the caution that you may find here. I've shared the link on the comment section below or the description below so that you can just do some correction on it. So let me see if I have any asset here to display. For this case, I don't have any asset to display, but I may create my own area of interest so that we can make this session quicker. So for example, I may be having a session here. Okay. So when I come to these editing tools here, I can just make my area of interest. Okay. Now you will notice that I have created a geometry here, so I can just put the geometry off. So you will notice that I have just created my geometry here, but that is my area of interest. So the next thing that we can do here, okay. Sorry for that. I just lost connection a bit. Okay, now the first thing that we need now is to create another variable for our Sentinel2 image. Okay, so and then you assign an equal sign, then you can just navigate to the data set. Then you can after navigating to the data sets, you can now open on the Sentinel dataset. Okay, now after coming to the Sentinel dataset, you will find there is a Sentinel-1 and Sentinel-2. So for our case, it's downloading a Sentinel-2 image and most probably the top of atmospheric reflectance. Okay, so you can just take this line of code here as it is, just copy it, then you can place it somewhere here, okay, in the variable that we have just created. So in the next step, we are going to assign a variable for filter 1. Okay, now this variable for filter 1, you will find that it is we are going to filter date. Okay, we are going to filter date. Okay, now here we have two dates to consider, that is the start date and the end date. So for this case, we usually start with the year, then the month, then we can start with the date. We can continue to the date, then the year again, then hyphen, then you can just give the month, then you can just give the date. Okay, so for this case, this is just for a sample demonstration. Now we can have another filter, that is a filter for that is add engine dot you are telling add engine to filter with bounds. Okay, and then you here on bounds, you can just know it's an outline. Okay, it's an outline that should be considered when the info is being conveyed. Now so we can have another filter for the metadata. So we have add engine filter for us. Okay, add engine filter for us. Now for this case, to filter metadata, we will add another feature here. Okay, add engine filter for us metadata that is less than okay, a metadata that is less than a metadata that is less than let's see the metadata of our image. So our image is Sentinel. Sorry for that. Our metadata is an Sentinel-2. It's a metadata for Sentinel-2 image. So this is the property of cloud pixel percentage. Okay, this is for filtering cloud cover. So you can just copy on this. Okay, you just copy on this, then you can just place it there. Okay, now this is a property, so you need to assign either a single or a double quote. Then after that, you will give the cloud okay, you can give a value of cloud pixels that you need to reach extent. So it is 20% cloud cover or less. Okay, so the next thing that we are going to do, we are going now to combine these filters. Combined filters. Okay, now for this case, we usually tell the add engine dot filter dot add. Okay, so we are telling add engine to add for us filter 1, filter 2, and filter 3. Okay, we are telling add engine to add for us the filter 1, filter 2, and the filter 3, isn't it? These are the values that I have just input here. So for this case, this F should be capital. Then the next thing now, we are going to give a variable for the filtered image. Okay, now for the filtered image, it is our Sentinel2. Okay, dot. Okay, so it's our Sentinel2 that is being filtered. Sentinel2 dot filter. Then we are filtering with our combined filters. Okay, now the next thing now, after doing the filtered image now, is to assign a median and to clip our image within our area of interest. So its image is equal to filtered now dot median. Okay, see, this is a function, so dot clip. Okay, and we are clipping within our AOI, isn't it? I think so far we are together. So this is the filter that I have just placed it here. So the next thing is to map dot center our object. Okay, object our object is within our AOI, and the zoom level we can give a 10. Okay, now map dot add layer, isn't it? Which is the layer that we are adding. We are adding our image. Now we shall assign a force color composite. I mean, this force will be used to replace with the visualization params that we shall set in the settings of the image that will be displayed. And the name of this image is our AOI as Sentinel2 image. Okay, so when we run this script, it should successfully run, but you can notice that there is an error here. So let's see. So you can see that it has zoomed to our area of interest, and this is the image that we have just gotten. Why has it come dark? Because we have set the visualization parameters as 4. So you can just navigate to the setting tool, then you can just give the true color band, that is band 432. Yes, then you can just give a custom of 100%. Then you can just click on apply. Okay, when you click on apply, then it should display a very beautiful image here. So let's try a custom of 3. Okay, and when I hit apply, then you can see that this is the image that is very clearly displayed. So you will notice that this is within the geometry that we just defined. So that is how you can do, even with using your area of interest that is available here in asset. So for example, to load your area of interest in Earth Engine, I have just shared a line of code that a video on this live session where you can just come to new, then you can just upload your shapefile here that you will use instead of this geometry here. Okay, now the next thing that we are going to do, which I need your attention for a minute. You will see that you will notice that we needed even a DEM, isn't it? So to have our DEM here, you will just come just type st, or you can just come and say dem. Okay, you can just, they'll see if there is a matching results. Now you will notice that there is now this that was displayed here, the blah 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 blah. There is this Copernicus, there is Australian. So you will just go with what is best fit for your research, or you but for this case I will just go with the NASA DEM of 30-meter resolution. So I will just maybe you can navigate to the bands. Okay, you can see the here. Then you can just check on the properties. You can check on the other questions. Otherwise, you can just come to the data catalog, where you will find the DEMs. Okay, where you will find the DEMs. So these are the DEMs. So for our case, we are going to go with the NASA. Where is the NASA DEM at 30-meter resolution? Okay. Okay, where is the NASA? We can just find it here. Okay. The same way, you can just come to the search bar here. Okay, you can just type the DEM. Okay, in the data catalog you can just type DEM, then you search, or you can click on enter. Okay, that was another way. Or you can just come to data sets, then you can search here. Okay, you can search here DEM. Let us see. It's a bit of loading. Hope we are together. You can just feel free to comment on our YouTube channel as these layers and display themselves here. So for this case, you can just click. As I've told you, you can just click on DEM. Okay. Now, as it searches the results, you can just be thinking of how can we do this? How can we do this? So we have said we are going to go with the NASA digital elevation that meter resolution, and now you will see a simple script right below it. When you open this script in the code editor, it will display you a world DEM. Okay, but for our case, since we only need the DEM within our area of interest, so I have just removed where to center it, but I am going now to see. Now this line of code here has been used to export the image collection for the DEM. Then this one is to display the elevations. Then this another one here is to show the terrain using the elevations. So when we need to clip it now, so for example, when I say variable, our AOI DEM. Okay, I can just say DEM, and when I give an equal sign and just click on slope, okay, and then assign a function to clip, and I'm clipping it with this our AOI here. Then I close the bracket. Then instead of displaying the slope, I am going to display the DEM here. Now that some adjustment that you can make on that code, but it's just a simple code. Even you can write it by yourself. So for that case, now you can run. Let us see if this function will display. Now you will notice that we have the slope here. Okay, when I turn off the slope, we are left with the AOI Sentinel-2 image. Okay, but also the slope, you can see it appears as such. Okay, this is my area of interest, and that is the slope. So you can maybe assign some palette to our slope to just to visualize it. This is just by the way, but it's just a matter of learning. So for example, you can add these ranges of colors with the different elevations. Okay, then with different elevations you can just add at least 5 just to display you well, and then you can click apply, and you can see our DEM displays as smart. Okay, so that was just by the way. So on our Sentinel image, we did not import our visualization parameters. That's why you will find still our image is in grayscale. So you can just give bad 4, bad 3, and bad 2 as the true color composite. Then you can give a custom stretch of a 3. Then you can apply, and then click on import. This image visualization parameters shall display here. Okay, so let us put off the elevation and see. So that is a DEM within our area of interest. So since we have imported, now we can replace the first name here with image visualization parameters, so that whenever we run the code next time, it will just display a clear image. So for this case, you can see, okay, you can see it there. So our image just displays as clear as it is, but the DEM was just by the way. We just need the DEM as it is for further analysis. So the next part that is very vital for this case is the exporting our data sets to our drive, ready for some other image, or making maps or other set of studies. Okay, so now under documents, you will find that there is a simple way to get the export of image format. So when I just click on export image, you get options to export your image to cloud, to export your image to drive. So for our case, I need you can just click on export to drive, then you can just copy this format, and you can just place it in your code editor. So we are not going to deal with all these parameters, but just a few of them. For example, we cannot deal with the maximum pixels, CRS. These is things that we should just set some other times. Okay, so for example, we can just come up to maybe Okay, can just come up to that point. Can just give an equal sign. So since this is a function, I mean, since this is a dictionary, we just need to start it with curly braces. Okay. Now, for our image that we need first to export is our image here. Okay, our image here. So we can just call it an image since it is already defined. Then the next thing that you are going to to put is some simple descriptions of our image. So you just give a full colon, then after the full colon you can just give a simple description of your image, for example Sentinel2. Okay, now then you can give a comma, then the next thing that we are going to define is the folder where we are going to store our image, that is tutorial. This will just be created in your hard drive or on your drive, Google Drive. Then now you can just hit on run. Okay, when you hit on run under task, you will see there is the run button here. Okay, so when you hit on run button, you will see the coordinates CRS. Then you can just give the spatial resolution of that image of yours. You can see we describe the drive folder, the file name we just gave it, then the file format is a GeoTIFF. Then you can just click on run. Okay, for the Sentinel is running. So when it is successful, you'll just see a tick mint there. A minute, please. The same way to our DEM, since it is same as it's just the same raster image, you can just now instead of exporting the image, we are exporting the DEM. Okay, as we named it here, and the same way then some description. Then when you click on run, you will notice that also the DEM part appears here. So since the Sentinel part appeared, so for the DEM, it is a 30 meter resolution, and we need it to be exported in the Google Drive folder, and it is a GeoTIFF, and its file name is just a DEM. Then you can hit on run. So when these processes are run successfully, now you can just you can just navigate to your drive. Then in the folder that we called tutorials, you can just download them from there. Then you can make your maps. That was all for this session. I can see the processes are still running. So any question, you can just place it in the comment section. So you can see for the DEM, it was successfully exported, isn't it? So you can just click on open in Drive. Okay, when you open it in Drive, you will notice that it created for us folder called tutorials, and inside that folder is a DEM with an extension of GeoTIFF. Okay, so when I click on the three dots here, then go to download, you will notice that it will scan the viruses, then it will download in your in your in your download tools there. So and maybe I have just opened it. You can visualize it. You can see even the Sentinel-2 TIFF has just completed. You can also do the same by just clicking there. Then you can click on download. Then also it should appear at this point here after scanning the viruses. But that is just over there. Okay, let's see, download. Okay, it is downloading now. So for example, for the DEM, I've just opened it in a DAS imaging. Okay, it is a raster image. Okay, can you see it? This is a DEM, so you can just correct on the alert problem. It's everything is just that simple. Okay, everything is just that simple. I don't know if you have seen on that session on that session on elders imagine, but maybe I can reshare it. Okay, let me reshare the screen so that you can just appreciate what we have just done. So I should reshare the screen. I should reshare the entire screen. Okay, and I should share it, this one here. So I'm sharing the entire screen now. So what I have done is navigated to my Google Drive. You can see on the tutorial folder. You can see on the tutorial folder here, I just created the DEM TIFF and the Sentinel TIFF. So when you come to this drop down here and click on download button, as I was saying, the Sentinel will be downloaded at this point. So when I hit on this tool here, it should open in LDAS imaging. Okay, so it is computing some params. Very nice. You can see now, just as we exported it, that was what I was talking about. I just seen that I did not show you. Okay, let's correct the. Okay, you can see. Let me put off the DEM so that you can just visualize the Sentinel image as it is. Okay. The session was that nice. Thank you for your patience. Goodbye.